Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to write vectors in component form, linear combination form, trig form. We're going to go over how to graph it and also how to find the magnitude of the vector. This standard is covered in pre-calculus and physics courses. Don't forget there are 2 practice problems at the end of this presentation that you can work on to demonstrate mastery of the material covered. If you'd like to gain access to our entire collection of math tutorials, just take a look at the links in the description below. Alright, the instruction for the problem that we're working on is as follows. We have to, with the given initial and terminal points, we have to find the specified vector in component and linear combination forms. We have to find the magnitude, direction, and the vector in trig form, and then we have to graph the vector. Okay? Alright, so for problem number 1, let's say we have the initial point P given by -8, -5, and the terminal point Q given by 6, -1, and the vector that we're going to work on is vector PQ. Okay? Alright, so one thing to note is that the letters tell you what the initial and terminal points are for the vector, okay? So P comes first, basically that indicates that this point is the initial point and Q comes next, so Q is the terminal point. And you see the arrowhead of the vector notation there also tells you the movement. You go from initial to terminal points, okay? Alright, so let's start off with the vector in component form. Alright, so in component form, the vector PQ can be found by using the formula. So it's going to be the run on the x component area. So the run is x2 minus x1. And then the rise would be in the y component area, y2 minus y1. Okay, so what is x1, y1, x2, y2? Well, if you think about it, the initial point will give us x1, y1, so it comes first, and then the terminal point will be x2, y2. Alrighty, so let's go ahead and substitute that into this equation right here. That's going to give us x2 minus x1 is 6 minus -8, so minus minus becomes a positive 6 plus 8, and then y2 minus y1 is -1 minus minus 5, which becomes plus 5. Alrighty, and then when we do our arithmetic computation of the components of the vector, we have 14 in the x component and 4 in the y component. Now note that the way the parenthesis is written, it's a pointed parenthesis, okay? This is the mathematical notation for vectors. Alright, so there goes your first answer, our vector in component form. Alright, next thing we're going to do, we're going to find the vector in linear combination form. Alright, so let's do that, linear combination. Alright, so how do we write the vector in linear combination form? Vector PQ in linear combination form can be found by using the formula run x2 minus x1 attached to an I plus the rise y2 minus y1 attached to a j. Okay, the horizontal component goes with the I and the vertical component goes with the j. We already know what our run and rise are because we already calculated it here. All right, this is our run right here. The 14 is our run and the 4 is our rise. Let me just specify it here so we keep track. So this is our run, and this is our rise. We keep using these over and over and over again. So I'm just going to substitute these computed values into the linear combination form. For the run part, we're going to put 14, so we have 14, and just attach an I to indicate is in the horizontal direction. and then the rise is 4. We already did the calculation, so put a 4 and then a j next to it. Ladies and gentlemen, this is the linear combination form for vector PQ. All right, so what we're going to go ahead and find next is the magnitude of the vector. All right, the magnitude of the vector can be computed by using the Pythagorean theorem or the distance formula. Okay, they are basically the same thing. So to find the magnitude of the vector, magnitude of PQ, the notation first of all is written using a double absolute value bar. So magnitude of PQ, that's how you write it, can be computed using the formula, the square root of the sum of the square of the legs. Okay, so think about a right triangle. The horizontal leg is a run, so it's going to be x2 minus x1 square. All right, and then plus y2 minus y1 square. That's the rise. Alrighty, so just imagine, this is just a side note, you have a right triangle like this. You have a right triangle and the hypotenuse is the vector. Okay, so this is the rise, which is kind of like the, let's call that B, and then this is the run. Okay, and then we can call that A, and the length of the vector is C, so you have C squared is equal to A squared plus B squared, and when you get C isolated, you have the square root of A squared plus B squared. All right, A squared is the square of the run, which is just x2 minus x1 square, and then B squared is the square of the rise, which is just y2 minus y1. All right, so A is x2 minus x1, and B is y2 minus y1. All right, so don't forget the distance formula is the same thing as the Pythagorean theorem using coordinates. Okay, all right, so that's what we're going to do. Now, let's do the calculations. We already know what our run is. Our run is 14, so we just square that. 14 squared plus, we know what our rise is. Our rise is 4. So we square that, and we take the square root of the sum of the squares. That will give us the magnitude of the vector. Okay, and then that equals, let's do our arithmetic calculations here. 14 times 14 is 196. So we have 196 plus 4 squared is 16. All right, so we have to find the square root of that. So 196 plus 16 is 212. So the magnitude of vector PQ is the square root of 212. Let's see if we can reduce this radical that we have here. All right, let's break it down. It's even, so we can take out a 2. 2 goes into 212. 106 times, we can also take out another 2. 2 goes into 106, 53 times, and we have a prime number. Okay, so these common factors repeat. That's a square, so the square root of a square is just the root. So the square root of 2 times 2, or 2 squared, is just 2. So the simplified form of root 212 is 2, and 53 is not a perfect square, so it remains in the radicand position. 2 root 53, ladies and gentlemen, is the magnitude of vector PQ. Okay, that's how long the vector is. All right, next we are going to find the direction. Remember, vectors have two components. They have magnitude and direction. So we want to find the direction of the vector. All right, so for part D, the direction of PQ. All right, so the direction of PQ is going to be given by theta. Now, when you have a situation where your vector has no negative signs in it, the angle that you get, which is the reference angle, is the same as the direction, okay? But when you have one or more negative signs in either the x or y or in both components, then you actually have to draw the angle and add 180 or subtract the angle from 360 in order to determine what the direction is. Alrighty, so in this particular case that we're looking at, the direction theta is the same thing as the answer we'll get when we take the inverse tangent. All right, so the direction theta is the same thing as the reference angle because, let's go over that again, there are no negatives here, but if there are negatives either in one or in both of them, you have to draw the vector to determine what the direction is. Okay, all right, so what is the reference angle that I'm talking about here? The formula to calculate the direction, which happens to be the reference angle in this case, is the inverse tangent of the rise over run. The rise is y2 minus y1, and then the run is x2 minus x1. If you think about SOHCAHTOA, okay, when you're dealing with tan is opposite over adjacent, right? The opposite of an angle in standard position is the run. Is the rise, and then the adjacent is the run. All right, so let's look at this triangle right here. So let's say this is theta in standard position. You can clearly see that the rise is the opposite, okay, and then the run is the adjacent. So which trig function relates adjacent, opposite, and the angle in SOHCAHTOA is tan. All right, so that's why we're using the inverse tangent here to use the sides to determine what the angle is. Okay, so in this particular case, the direction theta is going to be the same thing as theta reference. Remember, this inverse tan calculation gives us the reference angle of the vector. It doesn't always give us the direction depending on the sign of the vector. Okay, so we're going to look at the inverse tan of our rise. We already know what our rise is. Our rise is 4. And our run is 14. All right, so let's just go ahead and plug that into our calculators, and then we can determine what the direction is. All right, so let me make sure my mode is correct. Yes, it is. So we're looking at, let me clear that, the inverse tangent, second function tan of 4 divided by 14. And our answer is 15.9454. Okay, so this is our direction, which is also the same thing as reference angle, 15.9454 degrees. All right, so there goes the direction right there. Let's box that. And then now we're going to graph and then talk about, wait, what's the order? Let me see. We're asked to find the vector in trig form and then graph the final result. Okay, so let's find the vector in trig form first, and then we are going to graph it. Alrighty, so for part F, the vector in trig form, so trigonometric form, trig form of vector PQ. So what's the trig form of vector PQ? There are two ways of writing it. The trig form of vector PQ can be written as the magnitude of PQ times cosine theta, comma sine theta, or you can also distribute the magnitude to the components. It can also be written as the magnitude of PQ times cosine theta, comma, the magnitude of PQ sine theta. Alrighty, we're going to be using both formats for our answer. Alright, so PQ in trigonometric form is as follows. It's going to be the magnitude of PQ, which is 2 root 53. We already did the calculations before. Bracket, pointy bracket, cosine theta. Theta is 15.9454, comma, sine theta, which is 15.9454. All right, this is one way of writing it, or you can write it as pointy bracket 2 root 53, cosine 15.9454, comma 2 root 53, sine of 15.9454, pointy bracket. Okay, so that's how you write vector PQ in a trigonometric form. All right, let's go ahead and graph the vector. We're not just going to graph, we're going to also label everything that we need for this particular vector. All right, so we're just going to make a coordinate system. We have a point in quadrant 3 and another point in quadrant 4. All right, so the initial point P, was -8 and -5. So let's do that. So 1, 2, 3, 4, 5, 6, 7, 8. So that's -8. And 1, 2, 3, 4, 5. That's -5. So the initial point of the vector P is right here. And then the terminal point is at 6, -1. So we have 1, 2, 3, 4, 5, 6, and then -1. That's the terminal point Q. All right, remember a vector is a directed line segment. So you need to have an arrowhead starting from the initial point and ending at the pointing towards the terminal point. All right, so we have to put that arrowhead there to let our reader know that this is a vector. Okay. All right, so let's label the vector so that we can see the clear connection between all the work we've been doing and what we have graphed here. First things first, let's write down what the name of the vector is. This vector is vector PQ, and in component form, it can be written as, so vector PQ can be written as 14, 4, or if you want to write it in linear combination form, 14i, I'm writing, 14i, I is backwards, let me write it again, 14i plus 4j. Okay, so that's the name of the vector. The direction is the angle it makes starting from the 0 position. In this particular case, since both components are positive, the reference angle we got, which is 15.94 degrees, is exactly what the direction is. Remember, that is not always the case. If you have a negative in one of both or both of them, you actually have to draw the angle, you have to draw the vector in order to know what the direction is. All right. In the next example we're going to do, in the next installment, we're going to show you an example where you have negativity introduced into the vector and how it impacts what the direction is. All right, so there goes the direction. Now let's specify what the magnitude is. What is the magnitude of the vector? The magnitude of the vector is basically the length of the vector. Alrighty, so computer's acting weird here. So let's show you what that is visually. So if you measure the length of the vector from the tail to the tip, that line segment I have drawn right there, that's the magnitude of the vector. Okay, so I'm going to make it in blue. So from here to here, that's basically the magnitude of the vector. That's how long the vector is. All right, so let's specify that. This is the magnitude of vector PQ, the length, is given by 2 root 53. Okay, so this is basically how you write a vector in multiple forms, how to find the magnitude, the direction, and the graph. All right, now you're going to have an opportunity to demonstrate your mastery of what we just covered in the example. So let's go ahead and try these problems out. Instructions are exactly the same. So practice problem number 1. What if you have the initial point C given by -9, 5, terminal point D given by 6, 7, and you are to find vector CD. Find CD, the different forms, and the graph, and yes. Okay, and then number 2, what if we have vector RS with the initial point R given by -10, -2, and then the terminal point S given by, let's say S where -5, 6, and the vector that we are looking at here is vector RS. All right, so go ahead and pause this video at this time. Try out these problems, and then we're going to show you what the answers are. All right, hopefully you've had a chance to try out the problems. Let's take a look at what the answers are. So for number 1, the component form is, so let's write it down. Component form is 15, 2. And then the linear combination form is 15i plus 2j. The magnitude is the square root of 229. The direction is, the direction theta is 7.59 degrees. Okay? All right, and then for number 2, the linear combination form is 5, 8. Not linear combination, the component form. The linear combination form is 5i plus 8j. The magnitude of the vector is root 89. And the direction is 57.99 degrees. Okay? So hopefully you are able to get all the answers correct. Now, if you have any questions, oh, one more thing, let's write it in trig form. So in trig form, both of them, I didn't put that down. Trig form, trigonometric form for this, for the first one is root 229 cosine 7.59 comma sine 7.59. And then for the second one, the trig form is root 89 cosine 57.99 degrees, comma sine 57.99. All right, if you have any questions or comments about the whole process, just go ahead and paste it in the comment section below, and we'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of vectors, do give us a thumbs up or a like. Your positive feedback is very important to us. Don't forget to subscribe to our channel for updates to our page. We upload videos to our page on a weekly basis, so go ahead and subscribe and hit the notification button to get notified concerning our future updates. Questions, comments, or requests for math tutorials can be made in the comment section below, and we'll be more than glad to respond. A collection of math learning resources can be found on our webpage at mathgotserved.com. Do check it out. Thanks again for watching, and have a wonderful day. Goodbye.